Hello my dear students, I warmly welcome you to Sia's digital classes. In this lecture, we are going to discuss about one of the important problem. See first of all the statement of the problem. Define the order of the permutation. Find the orders of the symmetric group S7 and also determine the number of elements of order 12 and order 3 in the symmetric group S7. Okay. In this question, by solving this question, we are going to learn the proofs of the two type of permutation problem. That is one of the order of the permutation problem and the second one is even permutation and odd permutation. In the examination also we will get the problems based on the even permutation and odd permutation. For that also we are going to solve see the solution how you can find out the even permutation and odd permutation, and order of the permutation also we are going to find out here. Here in the problem is asking that to find the orders of the symmetric group S suffix 7. Okay, the permutation group we can define as symmetric group. Okay, so and S suffix 7 is the symmetric group of 7 numbers. Okay, 1 to 7. Order is 7. And determine the number of the elements of the order 12 and order 3 in S suffix 7. Okay, this is the one of the longest problem in the permutation properties. So observe carefully. First of all, I am defining the definition of the order of a permutation. The order of the permutation of a finite set written in disjoint cycle form is the LCM, least common multiple of the lengths of the cycle. Okay, in the previous lecture also I clearly mentioned you any permutation which existed in the arrow notation. Okay, this notation is called array notation. Array notation. In this array notation, you will exist 1, 2, 3, 4 and 4, 3, 2, 1 in this format. Okay, this notation is called array notation. Instead of this, in the examination, they will ask 1, 2, 3, 4, 1. This is the cycle notation. Okay, cycle notation is different and array notation is different. If they ask in the cycle notation, that cycle notation again you have to convert into array notation. Then you can solve the problem. Okay, this is the cycle notation. In that cycle notation, for example, here I am writing 2, 3, 4, 1. 2, 3, 4, 1 is the one cycle having 4 elements. Okay, having 4 elements. 2, 3, 4, 1. Then the length of that cycle is called as the total number of the elements. 2, 3, 4, 1. There are 4 elements. So therefore the length of the cycle is 4. Okay, the length of the cycle is 4. So therefore you can write in this format. Okay, 4 ni oka open bracket lo mention chesi, that is called as length of the cycle. So now we are going to find out the elements in the group S7 with their orders 12 and 3. So here we can see the example. I am taking one domain. This total value you can call it as a domain. In the domain we have 2 cycles. Okay, the first cycle is open interval 1, 2 and the second cycle is open interval 3, 4, 5. You can also put the commas, but whenever you have single digit integers, you can omit the commas. Okay, in between you can put the commas 1, 2, 3, 4, 5. But whenever you have single digit integers, here 1 and 2 are the single digit integers, then you can omit the commas. You can write directly 1, 2. Okay, so 1, 2, 3, 4, 5. The length of the cycle. Okay, this one is called one cycle. The length of that cycle is 1 and 2 are the 2 elements. So therefore the length of the cycle is 2. And the next here we have 3, 4, 5. 3 elements are there. Length of the cycle is 3 cycle. So therefore order of the cycle 1, 2, cycle 3, 4, 5 is given by mod of cycle 1, 2, cycle 3, 4, 5 is equal to LCM of their lengths. Here length is nothing but first cycle length is 2 and the second cycle length is 3. So for those 2 lengths we have to find out the least common multiple value, LCM value. So the LCM value of 2 and 3 is given by 6. Okay, because 6 is the common multiple for 2 and 3. In this format, to get the order of any permutation, first of all that permutation we have to split into disjoint cycle. Okay, we have to split into disjoint cycles. After disjoining into the different cycles, then we have to take the lengths of the cycle. After the length of the cycles, we have to apply the LCM for the lengths. Here we have two cycles with the different lengths. One is the 2 cycle and another one is the 3 cycle. LCM of 2 and 3 is equal to 6. 6 is the order of this permutation. Okay, order of that example permutation. Now we are entering into the problem. To find the orders of S suffix 7. Okay, here you need to know that S suffix 7 is the symmetric group and you don't know how many number of the permutation in that set. Okay, so to know the total number of the permutation in that set, you have to apply the factorial value for that suffix. Okay, here we have S suffix 7, suffix value is the 7. 7 factorial is 5040. 5040 denotes the total number of the permutation in that symmetric group. Okay, for example, if you have S suffix 3, okay, 3 factorial is equal to 6. There are only 6 permutation in that symmetric group. Next, if you have S suffix 4, 4 factorial, 24. 24 permutation. In that format, if they ask any symmetric group, the suffix value you have to apply the factorial, then that gives the total number of the permutation. Okay, now out of 5040 permutation, we have to find out the orders of them. Okay, each and every permutation is degree is 7. Degree is 7 is nothing but all the elements in that permutation will be 7 numbers. Okay, up to 1, starting with 1, ending with 7. 7 elements will be there. That total number of the 7 is called degree of that permutation. Okay, the 5040 permutations having degree 7 only, but we have to determine their order. So now see here, there are 7 factorial, that is 5040 elements. Elements are nothing but here permutations. Okay, 5040 elements of the symmetric group S7. To find the orders of S7, we need to only possible disjoint cycles of the elements of S7. Okay, so disjoint cycles. So first of all, to find the orders of the given group, so first of all we have to split that group into disjoint cycles. Now you can see here, consider we denote an n cycle. We denote an n cycle. N is nothing but length of that cycle. Okay, in that cycle there are small n number of elements. Okay, that way I am taking it as a n cycle. Now that n cycle I am denoting it is in the format of bracket of n. There are 2 elements, bracket of 2. If there are 3 elements in the cycle, bracket of 3. Okay, for the convenience of our proof, okay, we are using that notation. We denote an n cycle in the format of bracket of n. That gives the meaning of there are n number of elements in that cycle. So by arranging all the possible disjoint cycle structures of the S7 according to the longest cycle, lengths from left to right. Okay, you can see the first cycle having 7 elements. Okay, the first cycle, that is the biggest cycle in S suffix 7. In that cycle there are 7 elements are there. Okay, that's why I am writing as open bracket 7. That gives that meaning of there are 7 elements in that cycle and there is no other cycle. So therefore directly you can write order is 7. We cannot take the LCM. So therefore order is 7. Next, after 7 number of elements, now we have another domain. Okay, 6 numbers in one cycle and 1 number in one cycle. Okay, this type of permutations also exist. Out of 5040 permutations, 6 number of elements in one cycle and 1 number is one cycle. If you add them, again you will get 7 elements. But this is also one type of domain. Okay, now here 6 is the different cycle and 1 is the different cycle. 2 cycles are there. Take the LCM of 1 comma 6 is equal to, LCM is 6 only, and that 6 is only called as a order of this domain. Okay, this 6 comma 1 is the LCM, that is equal to 6, that is the order of that domain. Next to domain. Okay, here we have 5, 2. 5 is the one different cycle. Okay, the total number of elements are 5 and 2 is the another cycle. So okay, now you have to take the LCM of 5 comma 2. LCM of 5 comma 2 is equal to 10. Therefore, order of these type of domains, okay, if these type of permutations are there in 5040, out of 5040, those type of permutations are exist, then that order of those type of permutation is equal to 10. Next, another domain 5 1 1. If you add them, 5 plus 1 plus 1, 7 only. There should be 7 elements. Degree will be 7, but we are dividing that cycle into disjoint cycles. So therefore 5 1 1. Therefore length of LCM of 5 comma 1 is equal to 5. That is the order of that domain. In this format, next first 7 we took, after 6, after 5, 4, 3, 2, 1. In this format we have to come up to longest cycle to least cycle. So now after 5 we have 4. For 4 we have to add 3. Okay, then you will get the 7. So okay, 4 3. For this domain you have the LCM 4 comma 3 is equal to 12. In the examination, okay, in this question he asked that find the elements of order 12. That means we have to calculate the total number of the permutation in this domain. Why? Because there are 5040 permutation, 5040 permutation. Out of 5040 permutation, we have to calculate the permutation which having order 12. Okay. Now here another domain is 4 2 1. Okay, this 3 only again divided into these two cycles. So therefore LCM of 4 comma 2 is equal to 4. These type of domains order equal to 4. In this format, next same 4 only, 1 comma 1 comma 1. So therefore LCM of 4 comma 1 is equal to 4. That is the order of this type of domain. For these 3 cycles are the domain of 4. Next these 3 cycles, these 4 cycles, okay, up to from here to here, these 4 cycles gives the order of the domain having 3 3 1 and 3 2 2 and 3 2 1 1 and 3 1 1 1 1. Okay, this is the domain having with least elements. So therefore the orders will be 3 6 3 3. Next this one is the another domain starting with 2. Okay, starting cycle is 2. Okay, so 2 2 2 1. Here 2 2 1 1 1. So in this format, here orders is LCM, you can find them. So 2 2 2. So therefore the 2 is the order of this type of domains. Next, the last domain. Okay, you can take all the single digit cycles. Okay, so we can ignore this, but for the purpose, from the longest cycle to least cycle we are writing. So 1 1 1 1 1, 7 ones are there. So therefore degree of the cycle is 7 and order. So LCM 1 comma 1 is equal to 1 only. So there, if you observe carefully from the starting, so first order is 7, next order is 6, okay, and 10, 5, 12, 4, 3, 6, 2 and 1. So there, that is only I am writing here. So therefore the orders of the permutations of S7 are 7, 6, 10, okay, 5, 12, 4, 3, 2 and 1. Okay, irrespective of their arrangements order. So now out of these orders you can also count them: 1 2 3 4 5 6 7 8 9. 9 types of orders are there. For the 5040 permutations, 9 types of orders are there. So out of 9 types, in this problem he is asking 2 types. The first type is 12 and the next type is 3. Okay, now to find the permutations of order 12, okay, so you have to go back to the previous one. Okay, the same problem only. Wherever you are getting that order 12, that domain you have to select. Okay, here you can clearly observe that 4 comma 3 is the domain. There only you are getting order is equal to 12. So now we are going to the domain. The only domain of the order 12 is 4 comma 3. So therefore now that domain, what are the numbers? Okay, that domain how it will be, now we are seeing. Consider A1, A2, A3, A4, A5, A6, A7. I am taking in the general format. I will also explain with the numbers. Okay, so for example 1, 2, 3, 4 is the first cycle and 5, 6, 7 is the second cycle. the total number of the elements is equal to 7, degree is 7, but we are taking that is into the another domain. So now we have to find out the permutations, total number of the permutation in this domain. So first of all I am saying that is the domain of disjoint cycles of having order 12. Now for this first cycle, here we have two cycles. First we have to find out the order of this cycle, and next we have to find out the order of this cycle. For the first cycle, A1, A2, A3, A4. Instead of A1, A2, A3, A4, imagine 1, 2, 3, 4. Okay. The number of ways to fill these slots are 7, 6, 5, 4. Why? Because we have total numbers. Okay. So I can explain with numbers. 1, 2, 3, 4 is the first cycle. This first cycle we have possibilities. For if you take any permutation, you have to fill the 7 elements. Okay, 1, 2, 3, 4, 5, 6, 7. Out of these 7 elements, the possibilities for the required slots. Here in the first slot, you can fill 1 7 times. Okay, so you can fill the 1 7 times. That is, I can write clearly. First element, whatever you can select, that element you can fill 7 times. Okay, and the next element 2. That 2 comes in the second place. After 7 possibilities, this 2 having 6 possibilities. Okay, so next third element is the 3. That element comes under the third slot. So after 6, then 3 have 5 possibilities. Next 4. Okay, for this 4 you have 4 possibilities. Okay, in this format 1, 2, 3, 4. 1, 2, 3, 4 is the cycle, and in this cycle for each and every element, first element having 7 possibilities, second element having 6 possibilities, third element have 5 possible, and fourth element have 4 possibilities. 7, 6, 5, 4. This product value gives the total number of the slots, total number of the cycles which having the different place. Not only taking 1, 2, 3, 4 in order, you can also take 2, 3, 4, 1. Okay, next this 3 comes here, 3, 4, 1, 2. Next this 4 comes here, 4, 1, 2, 3. In this format different cycles will exist for you. Okay, this total product will give the total number of the cycle. That product you have to divide with 4. Why? Because the length of the cycle is 4. There are 4 different elements are there. So that is only here we are seeing that. Okay, so therefore for the first cycle A1, A2, A3, A4, so the total number of ways to fill these slots are 7, 6, 5, 4. You know how I explained that, how you will get the 7, 6, 5, 4. Then this product value counts the cycles A1, A2, A3, A4 4 times. Why? Because 7, 6, 5, 4 are the different slots. We are counting those cycle in the 4 times. So therefore that is the first cycle is A1, A2, A3, A4. In the next cycle, A2 comes in the first position, then A3 second position, A4, and the A1 will goes to the last position. That is the second type of the cycle. In the third type of the cycle, A3 occupy the first slot, A4 will be the second slot, A1 will be the third slot, and A2 will be the fourth slot. That one is the third type of the slot. Next, last cycle is A4, A1, A2, A3. These are the different types, 4 types of the ways to get the numbers. Now, the first slot, if you any type of the cycle, the first slot is booked by 7 elements. 1, 2, 3, 4, 5, 6, 7. 7 different elements will occupy the first place. Out of 7, 1 element is fixed here. Then remaining 6 position, remaining 6 elements, we have 6 possibilities for the second slot. Already 2 elements are fixed. Remaining 5 elements, we have 5 possibilities for the third slot. Out of 7 elements, 3 elements are fixed. Remaining 4 elements, we have the 4 possibilities for the fourth slot. By the total number of the cycle is 4. So you can calculate this value, you will get the 210. Okay. So 210 permutations having that cycle of 4. Now the second cycle. Here the second cycle is A5, A6, A7. For this second cycle, we have 3 to 1 by 3. Why? Because here we have the possibilities. Possibility slots are 3 only. So therefore, 3 to 1 by 3 is equal to 2. So therefore, 3 will get cancelled. 2 is the value. Now I am taking the total domain A1, A2, A3, A4, A5, A6, A7. So therefore, for A1, A2, A3, A4 we have 210, and for this cycle we have 2. If you multiply them, you will get that 420 permutations are there of degree 12. Okay, simply first page. In the first page we are simply writing here that this domain, okay, domain 4 comma 3 having length of 12. Okay, there are 420 permutation. Okay, but if you count all of them, you will get 5040 permutation. Next we are going to find out the degree of 3. Okay, sorry, order of 3 permutations. Now for this order we have to find out the possible domains. Possible domains are nothing but here we have two possibilities. The first possibility is A1, A2, A3, A4, A5, A6, A7. That is the first possibility. Next to A1, A2, A3, A4, A5, A6, and the last one is the A7. These only the possibilities to get the order 3. Now in first case, in this case you will have, okay, so 765 for this circle. You will have 765 by 3. Now here for this one A4, A5, A6 you will have 432. 432. Okay. This A7 represents 1 by 1. Okay, because the length of the cycle is 1. We can also ignore. Okay. In multiplication, if you put 1 or not, the value does not change. So therefore 765, 432 into 1 by first 3 cycles and next 3 cycles into 1. But in this product, A1, A2, A3, A4, A5, A6. If you observe carefully in the second domain, this length of these 2 cycles is same. Okay. But if you get the reverse cycles, that means A1, A2, A3, A4, A5, A6, and the next immediately A4, A5, A6 and A3, A2, A1. The same cycles only, but we are getting in the reverse format. Then these 2 cycles will count the number. Okay, different number you will count, but in the calculation we will get only one permutation only. So therefore, but these products counts as distinct when they are equal in the group. So therefore, now the final multiplication we are taking it as 765, 432 into 1 by 3. This 2 gives the redemption value. So therefore, if you calculate that value, you will get the 350 permutations of order 3. In this format, we can find the permutations of order 12, 3, 4, 6, 7, 5, 2 and 1 also. Okay. So if you add all of them after finding the all permutations of different degrees, there are 9 types of degrees are there in S7. We find only 2 degrees. Okay. 2 orders. So if you find all the orders of the all permutation, if you add them, you will get 5040 permutations. So those are the total number of the elements, total number of the permutation in the S suffix 7, and those are the orders. In this format, if any question if you get in the examination, you have to do the same process. Okay. So this is the one of the important problem. Okay. So make a perfect practice and prepare well. Until I hope you understood this problem very well. In the next lecture, we are coming with another topic. So until bye, thank you.